Hello everyone, and welcome to the second webinar in NCC Group's IT/OT Safety Convergence series. The series looks at the unique challenges and opportunities from bringing together legacy operational technology with modern networked and internet-facing systems. So lots of organizations are harnessing the benefits of that IT/OT convergence, predictive maintenance, better shop floor efficiency, more visibility in terms of what's happening within your industrial facilities and environments. But with that comes certain cyber threats and cyber risks in doing so and navigating that journey. So the first session covered how to prepare and baseline and basically do the diagnostic on your plant or facility security. So we talked a lot about the baselining and getting ready for deploying OT security into that environment so you can harness OT and IT convergence in a safe and secure way. And talking about bringing together different groups within the organization across engineering, safety, and cyber. So I'll just give you a bit of an introduction and overview if you're new to NCC Group. We're a global professional services and managed services business operating from our headquarters in the UK across Europe, but also with operations in North America and across Asia Pacific. So globally, are about 2,500 people covering 4 core domains, really. So we have our technical assurance capability, where we're doing a lot of work around security testing across all sorts of different systems and infrastructure, right down to kind of hardware level, and deep technical expertise within that division. And then we have our risk management and governance capability, where we're helping organizations and customers navigate the complexity of global regulatory frameworks and different standards across cybersecurity. We have managed services, so we have a 24/7, 365-day-a-year security operations center, where we're monitoring our customers' systems and networks, including into the OT and industrial environments, to look for indicators of compromise and any indicators that they are being attacked, so that they can handle those in the right way. And then finally, when things do go wrong, and sadly they do, we have a digital forensics and incident response capability, and we're often coming into customers to help them with that situation where they've had a compromise that may have been picked up by our managed service, and then we can help them navigate through that safely and minimize the impact on their businesses. So that's a bit about NCC. Within the industrial markets and around IT and OT convergence, we're working across energy, water, utilities, manufacturing, transportation. And we often start with our facility due diligence service, which is really that diagnostic piece. So we look at asset discovery within those environments, threat and vulnerability assessments. We'll look at risk assessment, architectural analysis, and then, of course, what I touched on before, that regulatory compliance that customers are having to navigate at the moment around forthcoming regulations and new regulations that are coming into their various regions. In Europe, with Cyber Resilience Act, we've got NIS2. In the UK in particular as well, we've got the Cyber Security and Resilience Bill coming in at some point as well. And then finally, that continuous monitoring in our SOC across IT and OT, partnering with tech leaders like Dragos to provide that capability on OT monitoring. So that's a bit about us. I'll do an introduction to myself. My name's Sean Arrowsmith. I'm Director of Industrials at NCC Group. I work predominantly within the UK and European markets, but obviously as a global business, working closely with my colleagues across North America and APAC. I manage the team that looks after our customers across those individual sectors that I already touched upon. So doing a lot of work across the utility sectors in water and energy, also in manufacturing and transportation. So that's me, and I'm delighted today to welcome our panelists in Josh, Jim, and Robert. And I'm going to ask them to introduce themselves to the audience now. And I'll start with you, Josh.
Yeah, thanks, Sean. So Josh Cleet, I'm the Transport Assurance Practice Lead focused on North America here at NCC. I've been with NCC for about 3.5 years. Before that, I was with a large consultancy for about 10 years, also focusing on transportation for the majority of that. And then way back, I was a transportation officer in the Army. So a lot of transportation related time. Our practice is a bit different than a lot of NCC, not all of NCC, but a lot of it, and that we're vertical focused, right? So as it says, I'm focused on the modes within transport, really automotive, maritime, aerospace, rail, and providing the lens of all of our and delivering all of our services within the industry, right? So not necessarily functionally focused, but vertical focused. So we have a team, a global team, really, of transport expert, domain experts, right? So folks that have been either automotive engineers or ship captains or avionics professionals in the military, but who have also have deep knowledge of cybersecurity. So what I like to think our team does is we solve security problems. So if there's a particular problem, no matter what it is, if it's on the OT side, IT side, even product development and safety side, we'll usually matrix in our experts like Jim for OT or Robert for safety.
Excellent. Good to have you here today, Josh. And Jim, do you want to go ahead?
Absolutely. Thanks. Thanks, Sean. So yes, I'm Jim McKinney. I'm practice director here at NCC Group in North America. I've been here about 7 years now, and we have a practitioner-focused team. As Josh said, we emphasize people who've worked in the industry, have worked on the floor, so to speak, and gone through a lot of the challenges with integration and digital transformations, as well as just trying to maintain a reliable environment. So I've got experience in both operational IT environments for a little over 2 decades now. And through that 2 decades, we've seen a lot of changes, a lot of opportunities, and then a lot of things have happened. So I look forward to speaking with the group today about these things.
And last but by no means least, over to you, Robert.
Thank you, Sean. Hi, everyone. I'm Robert Stroud. I'm a consultant safety engineer in Adelaide, which is now part of NCC Group, but has been an independent company working in the area of safety for the last 30, 35 years. And Adelaide is a products and services company, so we do consultancy around safety and assurance, but we also have a product that helps you put together your assurance case, which is called ACE, and that's very widely used around the world. It's probably the leader in that particular field. My introduction to this topic of today is security and safety. It was about 15 years ago when we were approached by the UK Centre for the Protection of National Infrastructure. It was a bit like the Department of Homeland Security in America. And they said they'd heard about this new railway signaling system that was going to be connected to a mobile phone network. And they said, although we know that the railways have always taken safety very seriously, perhaps they're not so familiar with security, and maybe we were a bit worried about what the security implications of putting these two technologies together. And so we did a security audit of this from a sort of safety point of view, and one thing led to another, and developed training courses on security-informed safety, and really came to understand that if your system isn't secure, it's not safe. You can't claim it's safe. So if you think your system is safe, but you haven't thought about security, you need to think again.
Okay, good to have you here, Robert. And it's great to have someone from our safety division and across the different regions in terms of our North American colleagues as well. So just a bit of housekeeping before we get into the kind of main content of today's session. There is a Q&A functionality, so I'd really encourage the audience to place questions in that, and we'll pick them up towards the end of the session. It would be really good to get that participation. And on that point as well, there will be a number of polls that we're going to drop into the platform as we go through today's webinar. So do please participate in that. It'd be really interesting to get some views from the audience in terms of the questions that we asked there. Before we get into the kind of main area of the webinar, I'm just going to ask Robert from a safety perspective and safety and security to talk to this slide, because I'm really interesting to get his perspective on this before we get into the main questions.
Yeah, so thank you. As the introduction to the webinar said, safety and security are in some sense the two sides of the same coin, and that this is what this slide illustrates. So in a broad term, safety is about the damage the system can do to the environment, which is particularly relevant for operational industrial control systems where there's this cyber physical element. You're not moving money around or information. You're actually having a real kinetic impact on the real world. You're doing something physical. And security is about the damage that the environment, in a broad sense, can do to the system. and so you're concerned about if your system was compromised, then it would effectively do damage to the environment. The things you would be worried about would be a loss of integrity, which would mean the system did dangerous things, or a loss of availability, which would mean the system didn't do anything. And if the purpose of the system was for safety, that would be a concern. Now, when you realize that the environment is just another system, they both have people, processes, and technology in them. You see how they mirror each other. Both of it's about what the threats they pose to the other and how you manage those threats, how you try to mitigate the effects of them, how you try to prevent them from occurring in the first place, limit what happens if they do. So in that sense, the two things are very closely connected, and you would use the same sort of ideas and same sort of techniques to talk about understanding those threats. Even though people might use different terminology, they're basically doing the same kind of analysis to understand what might go wrong and think about what they could do to prevent it from happening.
Excellent. It's good to get the kind of the safety angle there, Robert, particularly because we often come at it just from cyber, but bringing your view in is really fascinating. So we'll move into the main sort of set of questions for today. So question one is really around, and the poll is just been posted as well. So whilst we're getting into the first question, if the audience could take a look at this poll in terms of how your organisations have they combined safety and security teams? Could you respond to that poll whilst we get into the main content? So the first question is, how can companies develop a unified safety and cybersecurity culture that resonates across all levels of the organization? This is really sort of picking up on the theme from the first session that we had, and this is about bringing different teams together across different functions within the business and within these facilities. So I'm going to go to Jim first with this question. Good to get your take, Jim.
Sure. Yes, we've done quite a bit of work with different organizations as they've gone through like what we call digital transformations or just modernizations of technology. And I think a lot of times, as you said, Sean, there are different teams that need to begin to work together a bit more fluidly. And so there's some challenges there with people having different thoughts or different cultures, or even approaching things, different technologies and processes different. And so a lot of, I think, that's involved with creating a unified culture is just getting the teams to talk together, getting a common language, really engaging honestly with the frontline staff, because it's the frontline staff that have the challenges, and a lot of times they have the insights into actually what works, what doesn't work, how it's going to impact the line, their lives, their work, their processes, which all flows back up to the overall goal of the organization. So I've seen the go to the front lines approach pretty well. We have teams that go out on site, go into the environment, talk with the people, ask what things do, just what's going on, and then how does this work with the cohesive strategy that the organization is leading. So I think that's the top-down support is important, but also we get real insights from engaging directly with the operational staff as well.
Thanks, Jim. Yeah, interesting. It's sort of bringing together those different teams, isn't it, and trying to talk the same language there. And Josh, just your view in terms of the transportation side. And
yeah, sort of on the other side of what Jim was talking about. Obviously, the being on the floor, working directly with the engineers is extremely important. But that top-down piece have seen to be also extremely important, right? So if the leadership needs to buy in, right, and leadership needs to endorse it, stand behind it, right, and be that champion to push it forward. I think it's important for them the teams to work together. What I've seen that's been useful in other areas is if there's if the teams aren't combined, let's say, you have an IT security team, an OT security team, let's say, or an engineering team that's responsible for security, and then a safety team is doing rotations, right? If you have up and coming junior folks or strong performers that want to learn the different areas, do rotations in the other groups, right? And that'll help those folks understand sort of the methodologies and the perspectives that these other teams are taking, and can also inform them of the mindset of the other teams, right? And in the end, that helps with collaboration. It helps understanding how another team is approaching hazards or threats, or how they're putting in place controls, whether that's safety related or security related. And really, it's just going to increase resiliency overall, whether that's a potentially resiliency to an issue that's related to an equipment failure, right? That's unrelated to security, or there's a security incident that impacts safety. I've seen this in automotive, which is where I predominantly work, in the automotive side of the house, where you see a lot of the folks who have sort of fallen into cybersecurity as it's become a more focused area with product development and automotive design and development. They really come from the functional safety side, a lot of them. So because a lot of the sort of initial hazard analysis, threat analysis, the methodologies are quite similar. So that's always interesting to look at where security can learn from safety. And then finally, just making sure there's resources allocated, right? So that leadership also needs to continue to endorse and allocate resources for those rotations, for the continuous improvement of the process, people, and the technology.
Interesting. Thanks, Josh. That sort of tees it up quite nicely, I think, for Robert in terms of the the HAZOP. So yeah, get your view there from the safety side.
Well, that's very interesting. I mean, I agree completely with everything Josh has said, and also Jim. I think it's very important that if you're trying to build a unified safety and cybersecurity, it comes from the top in the organization. It needs to come down from board level. You need to have someone responsible for making it happen, and you need to think about your staff and what the competency and awareness and so on. You need to provide proper resources, set up processes, and all the rest of it. And one of the things we did for CPNI was we wrote some guidance on security informed safety. And the first chapter of that guidance is on policy, culture, and organization. So there's a lot of advice about the kinds of things you have to address there. And Jim was talking about the importance of getting on the factory floor and talking to people and seeing what's really there. And of course, this is always the case when you're assessing a system. You have a nice little picture of the system on the nice little diagram, and it all looks fine. And then you see a photo of it, and there's a little port on the side, or a little button that nobody mentioned. And you say, "What's that? What's that for?" "Oh, that's the thing to remote access." And you say, "Oh, remote access, really? Okay, that's interesting." So I think CPNI at one point had a really ambitious goal, which they called changing the way engineers think. And I think, and it was a generational goal. It was, it's kind of over for the next generation, and it fed into education. And the idea was to get people, I think, essentially make people be systems engineers who thought in a kind of holistic way about dependencies between systems and what would the consequences of failure would be, and how you would protect it, and how you would assess the impact, and all that sort of thing. So they wanted to essentially develop a kind of unified professional, a kind of cyber safety system engineer type person. And I think and I think it will come together. I think when I started this work 15 years ago, the word cyber didn't even exist. We were asked to do an information security audit, not a cyber security audit. And I think as the discipline evolves and develops, the two they will come together a bit more. Would you like me to say something about HAZOP, Sean?
I think that would be interesting, because I think Josh touched on that as a point that sort of brings groups together, doesn't it? So that'd be interesting.
Yes, that's right. So one of the techniques we use in safety analysis, and as Josh said, the techniques in security are very similar. We call it a HAZOP, a hazard and operability study, and the idea is to look at a sort of model, architectural model of the system, and look at the relationships between components. And then you have a kind of, you could think of it as a sort of structured brainstorming session where you use a series of keywords to think about what would happen if a component broke, or if it sent the wrong thing down a message, or impersonated somebody, or whatever. So you use a list of keywords and you analyze the consequences of a failure and what the impact of that might be further down the system. And you systematically go around the whole system applying these keywords. And it's a creative process, and it sparks off the participants. So what you want to do is get a whole range of people with different experience, different views, different opinions about the system in the same room. And then you get this synergy, and they sort of spark off each other. And I was in a room doing one of these, and there's people saying, oh, this is like being a James Bond movie. We've never thought of that, you know. And that's exactly the kind of response you want to get, because you sort of blue sky thinking about, well, what would happen if that happens?
Yeah.
Well, never happened. Well, why can't it happen? How do you know? If it did happen, how would you know? And you start asking those kinds of questions. And that's a really good way, I think, of getting safety and security people talking to each other and in the same room, understanding each other's perspectives, as Josh was saying.
That's a great tool, I guess, for a framework for bringing those different groups together, which is that's really interesting. Just going to go back to the poll. So we've had our votes are in, and the question was, does your organisation have separated or combined safety and security teams? 60% separate, 20% combined, and then 20% not applicable. So yeah, broadly still separate, but I guess, you know, more and more often working together, and in the way that you've described, Robert, and that goal for the NPSA and everyone else that you were touching on. I'm just trying to. I'm wondering if our moderators could remove the poll, if possible. Okay. Yeah, and go on to the next question, please. Okay, so thanks. That was a good insight, and that's sort of drawing on what we talked about in the first webinar, and it was very much that kind of preparedness, and we talked a lot about bringing those different cultures together. So now we're going to sort of move into looking at what role does technology play in achieving convergence, and obviously, you know, thinking about the cyber implications of convergence and IT/OT convergence, and deploying controls across different environments. And I'm going to go to Josh first on this one.
Thanks, Sean. So yeah, technology is obviously driving a lot of convergence, right? And most of it, I think we know, is around, you know, driving efficiencies. You know, how can you reduce cost? You know, drive up your profit margins, et cetera, be more competitive, and then as well from an operational perspective, right? And
Yep.
I think Robert or Jim touched on it, right? The ability to maintain equipment remotely and do things cheaper, right? Do it less expensively. However, this is, you know, the security aspect, right? It's going to open up attack surface, right? Think new considerations that you need to, you know, include in your HAZOP or your threat model from a security perspective. And I think it's important just to get, you know, cover the basics, right? And we probably talked about this a bit in the first webinar, but, you know, it really is some basic related things. You know your assets, right? Know the criticality of your assets. Implement those standard security policies, those controls. I think a really big one, at least within the transportation space, is the third-party risk management, the supplier assurance, which is just it's huge. It's critical. We're seeing that more and more as security becomes more of a spotlight within the transportation industry, and you can see that from some of the rules and regulations that are coming down from government as well about suppliers and sort of banning suppliers from certain regions. And then finally, just operational resiliency, right? And that's back to the people as much as it's technology, right? How are you making sure that you're drilling in those processes? The people are trained; they know what to do in the event of incidents. I think that the technology piece is also helping with that transparency and collaboration, right? Because usually different departments can see at least the data from different sides of the house, and can understand what's going on, and work together more. You know, back to the last question. But then again, you know, back to the people piece. It's not a silver bullet, right? Technology is not going to solve everything, and you can't rely on technology to solve everything. And also, as you implement new technology or you bolt on new technology to legacy systems, it's extremely important that every time you do that, to then do another assessment. You know, how does this impact my broader system, right? What are the new functionality and features which are helping my business from an operational perspective? But how could that functionality and those features be abused, right? Either from an attacker or maybe just from an insider perspective, or just a lack of training. How could they create a safety incident?
Yeah, interesting. Just continuously assess that risk if you're deploying anything new into environments, and making sure you do that securely. And Robert, your take from a safety perspective.
Yeah. So yeah, I mean, commodity technology is obviously making it much easier to join systems together and talk to systems remotely and things like that. But as Josh says, this brings in risks as well. It's convenient to be able to access your systems remotely rather than sending engineers out into the field. But you have to sort of manage that access. You've got to be aware that the remote access is possible. You've got to have appropriate controls in place. You've got to consider what the consequences are if some random hacker discovers this remote access. There's a wonderful website you might have come across called Showdown, I think, which is a kind of catalog of systems that someone found on the internet. There's a video I used to use in my training course of someone talking about all the things he found he could do remotely, including he could basically take over a complete stadium and control the HVAC and the fire alarms and all sorts of things. And then he gets onto traffic lights and it says, don't do this. This could be dangerous. And it actually warns you not to do it. And he could play with the traffic lights remotely. So, it's scary that these things are out there. And some of that is because commodity technology is being used and nobody has thought about how to lock down that commodity technology. And so it's important to have guidance that if you're going to use commodity things, you need to kind of secure them. And there's standard baselines for how to secure a Windows PC or whatever. And we have developed what we call low-fill guidance for low use of commodity equipment in low integrity safety applications, which is really about turning off all the features you don't want and making sure everything's properly controlled. But as I say, because of the commonalities, the kinds of tools you can use are quite have something in common as well. So I use software analysis tools to analyze software for safety defects, but somebody could use the same tool to analyze it for security vulnerabilities. So there's some commonality there. And ACE, as I say, is a tool for putting together an argument and communicating why you think your system is safe and secure. And so you assemble the evidence and you present it graphically to your stakeholders or your board or whoever it is have to sign off on the system. So things like that. And another example might be common notations. There's a wonderful notation I like called bow tie notation. And the left hand of the bow tie is all the things that could go wrong and that could lead to something bad happening in the center of the bow tie. And then the right hand side is what you can do about it. And there's a thing I call a cyber security bow tie. Left hand side, keep the bad guys out. Right hand side, limit the damage if they get in. And that's safety thinking, that's systems thinking, and that's what you need. And these tools and notations can be used for both safety and security and help bring things together.
Yeah, and a good way to approach it. I mean, obviously, businesses are forever charging towards the benefits of new technology deployment, aren't they? But not thinking necessarily about the risks until later, and that's having that structured approach is really important. I did see that the rail industry are publishing another bow tie method quite soon, and a tool set that's coming out. So it'll be interesting to watch.
Yeah,
in the UK.
The other thing is, of course, the creeping functionality. So that somebody sort of adds some remote access capability to some widget they sell and don't mention it because so you think you're buying something that you previously assessed, and it actually has some extra bit of functionality added to it that represents a serious security risk, and you need to be aware of that somehow.
And Jim, I know that you do a lot of work in interesting environments and all sorts of different facilities and what have you in terms of industrials and stuff. So it'd be really good to hear your experiences from walking the floor and kind of what you see.
Absolutely, and as Robert and Josh talked about, I mean, I think efficiencies and the ability for like remote access to provide not only scalability to support these systems or these areas that are kind of out in the middle of nowhere, which is quite a bit of what we work with. But it also prevent, you can also use that so people don't have to enter the environment, right? And so there's a lot of good things that come from technology. But honestly, I think probably one of the best the best impact from like a new technology, like it's a business case, right? The business is going to produce more. It's going to be more efficient. It may have a reduced labor cost as well. And that's a business case. And so a lot of times the constraints we see in security would just be there's not a lot of OpEx budget, right? And
Yeah.
so if an organization's investing in the future and technology like a digital transformation, it'll be a capital budget. And that capital budget is, if it's used not only to enhance the technologies and the processes and the production capability, but also looks at some of the risks, as Josh and Robert were saying. And in that capital, in that plan, you're bringing in and planning for what's the weakness, what's the risk, how do we account for these things? And so that tends to open up a lot of budget that's not typically available with security or maybe even safety in these areas. And it just becomes an integrative whole. Then you have teams working together for a common good, a common purpose, and there's monies and time available to do it the right way, so to speak, and versus kind of peg it together while they're still working.
Interesting. Yeah. Thank you, Jim. So I'm moving on to the third question, and this one's around what lessons can be learned from real world incidents where IT/OT convergence, where you've seen it enhance industrial safety and also where you've seen it potentially compromise. So Josh, get your take, please.
Yeah. So I guess from a more general perspective, there's those pros and cons again around implementing new technology, the convergence side, specifically as it pertains to safety here in this question. So, for example, just on a call with a client the other day around potentially assessing some new technology they're implementing specifically for safety, right, within a large warehouse environment, right, where they're putting technology such as Bluetooth Low Energy or ultra wideband devices on material handling equipment, and also have sort of anchors across the large warehouse, for better localization of this equipment, making sure they're in the right lanes, they're not going off track, they're not going to run into people or where there's walking lanes, things of that nature. So obviously that should improve safety. But back to the point we were talking about before, you need to make sure you're doing the proper analysis before you implement it, right? And understand the risks, understand the threat scenarios, and prepare for those. I think it's also interesting when we're looking at some of the real world incidents that impact OT or have impact OT from some perspective. A lot of them start from a compromise on the IT side of the house, right? So either it's an IT, it starts out as an IT compromise, and then they somehow get into the OT network through some connection that someone didn't realize was there, or the organization simply decides we're going to just shut down OT operations out of an abundance of caution, right? I think there's plenty of situations where that has happened in the past few years. I think that there are the real world help, though. Again, we talked about the efficiencies, the use of more data analytics. You can also use those analytics we've seen for more or better logging and monitoring, right? Better understanding of what's going on the shop floor, or what's going on within particular areas of a large vessel or ship perspective, which can then help with warnings and response times and things of that nature, both from a safety and a security perspective. I think in other situations we still also see a lot of misconfigurations of the various IT and OT networks, right? Just based on a misunderstanding of what's actually deployed. The design differs from what's out there. And if that happens, right, the controls that you implement, you're obviously going to have some blind spots. You're going to have some gaps. The other things from sort of not necessarily incidents, but real world work, and we're thinking about sort of the system security engineering piece, which Robert talked about a bit. I worked a lot more recently with our Adelard colleagues on some of the assurance cases, right, in developing new automotive architectures, right? So if we think of innovative automotive architectures, particularly from an autonomous perspective, you can establish that And also Jim was talking about this, right? You establish the business case, or you establish the business objectives of what this product is going to do. I mean, I'm thinking more on the product side rather than the sort of a plant perspective here, a manufacturing plant. And then you establish those claims, you know, of security, of safety, those arguments against it, and then how are you going to prove it, right, with your evidence within an insurance case. And I think that's particularly helpful in telling that security story, but also managing incidents, right, and managing the operational perspective as you are bolting things on, and you can go back to that case and evolve it. And I think this is really helpful from a sort of a new build or a greenfield project perspective, but also from a legacy environment perspective. Other incidents, I think we're seeing the industry and government response to some of that, right? I think specifically in transportation, the ISACs are becoming a lot more prevalent or involved, a lot larger, more members, more collaboration. Particularly, I think of the automotive ISAC and the maritime, or the maritime transportation system ISAC. New standards, right, that usually are pointing much more to system security engineering related processes. So I think of ISO SAE 21434, which is around automotive cybersecurity engineering. You have TSA, the Transportation Security Administration, security directives, which are a lot of the new ones are around pipelines, right, in response to the Colonial Pipeline incident, or the rail industry, the airport infrastructure side as well. And we know government regulation sometimes doesn't work out the best, but if you really look at the regulations, they point back to the things that everybody should be doing anyway, right? So understanding what you have, the criticality of your assets, making sure you have basic controls in place, you're monitoring.
And it's, I mean, often it's all very positive stuff, isn't it? But it's often quite reactive, and still we need to kind of do that shift left thing, which is that security informed engineering in the first place, to try and avoid these situations and not be reactive to produce standards as an afterthought. So yeah, that's really interesting. Robert, what are your thoughts on that? I mean, obviously building the case.
No, I mean, it's. I was just thinking what Josh was saying about standards coming along. I mean, I think quite a few of these standards didn't exist, possibly weren't even a twinkle in someone's eye when we started doing this in the railway 15 years ago. But now there's a rail cybersecurity standard, there's an automotive cybersecurity standard, there's very clear cybersecurity guidance for medical devices, which are another safety related thing, you know, and it more generally in the in the industrial sector, we've got the emergence of 6443, which I think is matured greatly. I think 6443 probably was around in some form 15 years ago, but it was a few years before I became aware of its existence. And I think it's a good model, because it makes you think about the criticality of your, you know, it's about defining grouping your assets into sort of domains and thinking about how they're connected, and which are the critical ones and which are the less critical ones. And just to get back to the question, because we possibly drifted away from the question a little bit, what lessons can we learn from incidents that have either enhanced or compromised industrial safety? Well, I think the enhanced question is quite difficult, because obviously we can talk about the experience we've done to help support customers enhance their safety. But if we have succeeded in enhancing their safety, there's no incidents, and that's the point. The incidents are always the failures when something has gone wrong. And I think, but it's very much part of the safety culture that you learn from your failures. And you look at what went wrong and you think, why did my safety case or my security case not catch that? And what can I do to make it better? So I think that's learning lessons and doing it in a kind of blame-free culture is really important. And I think it's important to be aware as well that there's kind of different kinds of threats out there. So there's if we take something like WannaCry, which was just a sort of typical sort of virus thing that spread across the internet, attacking anything that exposed an out-of-date Windows file system. And that got into all sorts of places it shouldn't have got into. It got into hospital X-ray machines, and it got into freight terminals, and it got into, all sorts of places. It had a global effect, and it wasn't seeking anybody out. It was just looking for poor, basically incorrectly configured firewalls and with legacy, obsolete, unpatched technology behind them. And those systems should never have been exposed to the world in the first place. And anyone who'd done a basic audit would have realized, oh, what's that doing on my network? Why would anyone be sharing their file system with the whole internet? That's a crazy thing to do. And of course, no one's consciously doing that. It's just kind of happening by accident. And as Josh says, a lot of attacks start on the IT side, and then they, you open up the dodgy email or whatever it is, and your desktop computer gets infected. Ideally, the IT side should be insulated from the OT side. You should have very strict controls on what kind of data can flow across there. And so if anything does get into the OT side, you have to worry about how it got there and what firewalls or protections weren't in place. Of course, when you're up against a sort of cyber nation state type attacks, which one hears about, Stuxnet was the first example that got everybody worried. That started in the control system, and it was probably introduced into the control system deliberately by human means. But then it got out onto the internet. How did it get out onto the internet? Because some engineer connected his laptop to what was supposed to be a highly secure operational system. And so this thing that was very targeted actually came out that way. I think connectivity is really the big thing. I mean, if they can't reach you, they can't compromise you. So who can get to you? Where are your network connections? Where do you have an air gap or not? How would you know?
Well, whether there's an air gap in reality or not is a whole different question, isn't it?
Yeah.
Jim, just coming over to you on this question and your thoughts on technology and enhancement or compromise, and any examples.
Right. I think there's lots of examples out there, right? I think we hear about this pretty much every day in the news. Something happens. A lot of times what we've seen is just Windows vulnerabilities being exploited, and it brings down a website, right? That we've always heard about these things. But I think, as Robert was saying with the Colonial Pipeline attack, like that was an attack, a specific, well, I don't know, we won't say a specific attack, but that was a cyber attack that compromised the billing system, right, of Colonial Pipeline, but it had the asymmetric effect of shutting down operations, right? And so they weren't necessarily linked together, but if you're not billing, you're not collecting payment, then are you going to, push the gas, right? And so the downstream impacts on that were significant, right? We remember this is 2021. I can still remember half the supplies of the fuel on the East Coast is disrupted. I think Washington DC had almost no gas in their gas stations, right? We work with airports, Charlotte, Douglas International, like they started doing alternative fuels, right? And down in Texas as well. So there's opportunistic stuff, and then the things like Robert talked about with deterministic studies with safety. On our side, there's threat actors, and there's intent, and people observe these things. The Russians and these other groups, they observe these things and they say, we can do this, and we can direct this. We can find that little pin and pull the string and watch the whole thing fall down, and it becomes asymmetric with the cascading effects. And so that's the thing I think we need to, the lessons we learned is just because it's on the IT side, it's a billing system or this system, doesn't necessarily mean that because now you're integrated, right? You're integrated. And now I think of this as holistically, as Josh was saying, and those are the lessons we learn. Prepare for the black swan, right? And then you're ready for any event, instead of like incrementally looking at specific use cases, right? Or specific attacks.
Yeah. And that sort of incident response preparedness is always something that we focus on, right? So it's we got a quick question from the audience. I just wanted to put this one to you, actually, Jim. It's has NCC Group defined any specific assessment frameworks or control frameworks? And I guess within the context of these environments, and I mean, I suppose that we draw on various, but can you comment on that?
Absolutely, yes. we developed a program based on lots of experience with our practitioners, and we call it facility due diligence, where, the first part, as Josh and Robert are saying, is like, what do we have? What's my risk? What do I do next? Like these basic questions. A lot of times what's on paper, what we think is there isn't actually out, doesn't exist. We call that the as-is environment, right? And so what do we have? What's actually out there? Let's do full assessments. Let's talk to the frontline people. Work with them to figure out what's actually on the floor, what's there, what does it do, what's the landscape look like, and from that asset inventory, really that understanding, the common understanding, we can build a framework and then have teams come together and discuss what is the risk, why is this here, what can we do, what's the risk, how can we improve this if there is a weakness, how can we get instant response, how can we get our first responders trained up to observe for things so this cybersecurity team can be alerted if something suspicious happens. And so I think that's one of the lessons I think we've seen. And like our teams go out and do this on a weekly basis with organizations, and then that's the beginning of a complete journey, right? Because once you know what you have and what the risk is, you can get the next steps. And then we don't start at the end; we start at the beginning without the potential fallacies of false assumptions.
Yeah, and that coverage is important. So, you touched on 6443 as a standard.
Mm-hmm.
Robert, you were going to.
Yes, I mean, we've published guidance on security-informed safety and how to conduct a kind of risk assessment from that perspective. I think there's a link to it at the end of the webinar. If not, go to the CPNI NPSA website and just search for security-informed safety. There we are, UK National Protected Security Agency guidance on security-informed safety. So there's some information there that might be helpful. I think another thing that's happening in the UK is the National Cybersecurity Centre is thinking about how you assess security devices, and is adopting a kind of principles-based approach. So it's not so much about what tests have you done on it, or what it's about why do you think it's secure, and they argue that in order to demonstrate it's secure, you need to show that it satisfies certain principles, and then you build up your assurance case around those principles. So that's a methodology that is currently being developed and evaluated. And I think NCSC published some good guidance on risk assessment. They don't like sort of tick box approaches. They'd rather people thought holistically about risks and so on. And so that it's an evolving area, I think. But there's lots of good guidance out there. As far as controls frameworks are concerned, I'd probably go with the NIST 882. It's got some good baseline controls, and I think NIST guidance tends to be very good. And I think it's got baseline as well, hasn't it? And our LOSIL guidance is in some sense a baseline set of controls for commodity PC. So there is definitely things that ADLARD and NCC people have done in this area.
Yeah. No, that's good. And we do have another question. I think it's probably one for our kind of general threat intel briefings. Will you cover any threat actors, state actors, or any recent events in the UK? I mean, we talked a bit about, I guess, the kind of threat profile of threat actors and nation states with things very targeted like Stuxnet. But I guess one thing we certainly are seeing, and I've seen from various outputs, is a shift from highly targeted to more universal types of malware strains and actors that can compromise a wide range of different industrial systems rather than it being targeted on one specific device or in the same way that Stuxnet was. So there's certainly the kind of barrier to entry of getting into or deploying this type of attack is lowering, I think, and becoming easier for other threat actors to get involved.
That's definitely a worry. Something that the nation state can develop one week, somebody can post onto the internet the next week. And in fact, I think the code for Stuxnet is freely available on the internet, though you probably get locked up in prison if you download it. I think Jim touched on a really important point, which is about the collateral damage of things. So the example of the pipeline in America where everyone ran out of gas and so on. I mean, a good example was an incident that affected the CAA, the air traffic control systems last summer, and that was corrupt, basically bad data, and the system couldn't handle the bad data, and so the bad data crashed the primary and crashed the secondary. So suddenly they had no air traffic control system, and sorted out. They had to get the bad data out of the system somehow and reset everything. And that was, and that took them several hours. And you can imagine in several hours, a lot of disruption can be done to an air traffic process. A lot of people can be affected. So there's some serious lessons were learned from that. And one of the interesting points about that was the second tier engineer, who was the person who, should have been able to fix it. He had remote access, but he couldn't remember his password or something like that. So he wasn't able to log on. He had to actually drive in to I'm not. I was looking this up before. It's slightly unclear whether the problem was he couldn't access the system remotely, or the system wouldn't let him reboot the system remotely. But the point was he had to travel in, and that delayed things by another 3 hours and affected another 100,000 people.
Yeah. The knock-on effects are significant. So I think that's sort of brought us to the end of the session. I'm just going to do a quick go to each of you and just get a sort of final thoughts. When you're deploying security into these kind of converged sites, any final sort of thoughts on that? Josh, I'll start with you on that.
Yeah, I think it goes. I want to touch on one of the last questions around recent events, threats, et cetera, vulnerabilities. And there was a mention, I think, in one of the questions of recent, issues with distribution hubs and the transportation side. And I think that's a great example, right? If we're looking at the distribution side, right, there's so many. If you purely look at the infrastructure and the moving pieces, right, you have vehicles, you have hubs, transportation hubs, and transportation terminals. You have the roadway infrastructure, you have the rail infrastructure, you have all kinds of things moving around. And you need to track that, right? So there are fleet management systems, or there's other operational sort of management systems out there, and that's a perfect way to look at the convergence as well, right? So you'll have the IT side, you have the cloud infrastructure side supporting it. You'll have the web applications, the mobile applications that drivers may be using. You'll have the actual connected hardware that's on the on the vehicle or on the ship or on the crane or the material handling equipment on the site. So it's just a good picture of how diverse the environments are and the connections across all of these systems. So you really need to look at it at a holistic perspective and understand the data flows and risk and the threat scenarios.
Great. Yeah, thanks, Josh. And Jim, final thoughts?
Sure. Just like Josh said about it, I think honestly, like the move from a single purpose to general purpose is really the key here. And like we see this every day with virtualization. Nearly every environment we walk into has something virtualized, and a lot of times it's a lot of the SCADA systems. So the terminal servers, the HMIs, they've been virtualized. That ESXi box is the central pivot point. Right, that is the point. It's a commodity. It's everywhere. It's used everywhere. So a vulnerability in the ASXi environment can potentially impact the entire operations. I mean, literally the entire operations. And the other thing about that is the efficiencies. So we think about virtualization and we get Veeam and we do these real-time backups and all these, we get this high uptime. But what if the ransomware was over 60 days? What if the infection was there 90 days ago? Do we have backups that go back 90 days to restore? And so there's a rabbit hole we get into. Well, it's really good intentions. Thinking from like a safety case or a cybersecurity case is really important as we assume this technology is here and it does not impact operations, but it's virtualization. It impacts operations, even though the guys on the ground, like, they don't even know it's virtualized, right? It's still an HMI, right?
Yeah. Interesting. Thanks, Jim. And Robert, final thoughts from you?
Okay, so I think we talked a lot about remote access and so on, and even local access. And I think there are good reasons why you want to have IT/OT, why IT/OT convergence is happening. There's good reasons why your IT systems might want to be able to interact with your OT systems. But I think that has to be managed. You need to know who's talking to who and what they're asking about. And perhaps if you people talk about data diodes, which ensures that the data only flows in one direction. I think if the bad guys can get into your system from the IT system by exploiting a vulnerability, there's something not right there. And so you need to be. So this is what lies behind it. If you're not safe, if you're not secure, or if I put it, if it's not secure, it's not safe. If you have uncontrolled inputs into your safety system or your control system, how do you know it's safe? You have to make sure. It's classic. You feed bad data into the system and it crashes. So how can you be sure that only good things are being fed to your system if you don't manage the interfaces to your system? So that would be my message, I guess.
Great. So some final sort of takeaways around collaboration and transparency, and that's bringing the teams together, which we've touched on in the first session and we drew out today. If you're not safe, you're not secure. This is the bit that Robert spoke to from a safety perspective, and it's people, process as well as technology. So you invest in all those things to reach the right level of maturity from a security perspective. And plan. And I think in operational environments and industrial environments, obviously, you get a small window of downtime and opportunity to deploy these controls. So planning is absolutely critical. You get one shot, and the downtime on a factory, for example, is a loss of revenue, and you only get that window of opportunity to get it right. Just drawing your attention to the final installment in the series. So we're going to finish with our optimization. It's about maturing OT risk reduction. So you've deployed your controls, and now you're in the realms of continuous improvement and continuous monitoring. And we're going to host that on the 25th of February at 10 a.m. EST, 3 p.m. GMT, and 4 p.m. CET. So that will be promoted after this. You'll receive a follow-up, and please do sign up for that final installment in the series. And thanks for joining us. I just want to thank our panel. It's been really fascinating having people from different divisions and different regions across our global delivery teams, and really enjoyed today's conversation. Thanks for joining us, and we'll close off there. Thank you.
And thank you, Sean, for an interesting conversation. It's been good. And nice to meet you.
Thank you.
Thank you.
Thanks, Sean. See you guys.